hey, I didn't see you there. So, the other day, I was working with a module with Python called Turtle. This module works with visual design in especially mathematical equations. The reason why I was working with Turtle was because the day before I had seen this video by Veritasium. He was explaining bifurcation, and I really enjoyed that topic. So my attempt was to make a bifurcation model, which expectedly I flunked. So I just decided, well, bifurcation's cool, but I think all we're going to make is a simple fractal. And the first fractal that came to mind that was simple enough for me to do was tree fractals. A tree fractal starts at point 0, goes up to point 0.01, and splits into -1 and +1. But now these are at points 1, 2, and -1, 2. But I wanted it so that it wouldn't just stay a constant 1 growth, because that would make things look a little bit messy. So what I did was I wanted to have it split at each branch half. So that would be -1.5, 2, and then split from there, and then split from there to -0.5, 2, and so on. We would do the same from over here. So once I had figured that out, I decided I would try and make it. And I started working out an equation. That was the completely wrong approach, but it came out with some interesting results. So what I expected was, I don't know what I was expecting. I was pretty much just working with random equations that looked as if they were supposed to do something. What it did, and I didn't know how to use Turtle completely. Here's what I came out with. For 25 times, I wanted to draw a line that was a specific segment that was constant. So line length is equivalent to, let's say, 25. And I wanted there to be a line, and then it would switch approximately 180 divided by the amount of times the program had iterated. So iterated means gone over once. So pretty much how many times the program had looped. And I wanted it to loop 25 times. That means that I wanted to draw a line for 25 segments, and then I want to turn a 180 degree divided by the amount of times the program had run terms. And I came out with something very interesting. Something similar to that. We have an exact representation right here. But that wasn't exactly what I was hoping for, but it interested me all the more. I've messed with the Fibonacci sequence before, and I noticed some similarities with what you just saw and, well, the Fibonacci sequence. It starts, now, with the Fibonacci sequence, it usually starts from the outside and starts dividing inward. But on accident, I started from the inward and divided to the outside. So that means that started at 25, I don't know math. Started at 25 and started doing spirals to the outward. And since it was always moving, those spirals would be disconnected and would be changing. And then I realized, well, that's a lot like orbital mechanics. So with orbital mechanics, you start from a point. Let's say right here, this is the Earth. You go up, and since gravity is pulling you down, you want to move this way. And that way, it creates a diagonal force, which pulls it down, and if you continue adding force, it's just going to make this spiral. And that's when I realized, oh crap, I made a new orbital equation. And for as long as you keep the iterations going, let's say that we wanted to have a specific value, so let's say the length of the lines are 1, and that can represent miles, kilometers, whatever value you want to measure with when it comes to what you're orbiting. And you want to iterate that as many times as you want to see into the future, or how many times, say, the rocket's going to have thrust. So I did 25 times. That means that as the rocket goes up, one time, it's just going to go straight up. The second time, I'm going to turn 90 degrees, and that's 180 divided by 2. That's very easily 90 degrees. And then it gets a little bit funky. 90 divided by 2 equals... 90 divided by... Sorry. 180 divided by 3 equals some number, and it would just continue spiraling outward. A little bit like that. So, what I learned from this was that I suck at math, for one, and for two, a lot of accidents can be actually really interesting. Like, I see how this works now, but not before. Yeah, thank you guys for watching, hope you enjoyed. And I really don't have much more to say than that, so if you like these types of videos, willing to put out more. And once I figure out the tree fractal, which will probably be at some point in the future, I will go ahead and post a video on that, similar to this one. Who knows, maybe I'll have another mistake and it'll look just as cool, but besides that, so far, we're just going to stick with this. So, thanks for watching, hope you enjoyed, and see you next time. So, what I did was I started working out an equation for that, and I didn't exactly know what I was getting myself into.